Hey, what's up? This is Jeter Tutors, and I'm going to talk a little bit about slope. Hey, here's a broom. Here it is. This is a line. It has a slope. All right, so you get this a lot in Algebra 1, and you will encounter this all the way through Algebra 2, trigonometry, and even calculus. But what we're gonna do is just go over the basic idea of slope. Okay, so the basic idea of slope is how far you go up the dashed line divided by how far you go over. So what we generally term this as rise over run. Change that, over run. So what you'll see is this funky equation that says slope equals rise over run, and basically a verbal expression. Or you'll see y2 minus y1 over, yep, I should do it in the right color, y2 minus y1 over x2 minus x1. Okay, so that's the wild thing. You need four things, and the y's are the y component of a point. So here you would have a point down here. This point would be x1 comma y1, and this point up here would be x2 comma y2. Now you can see how if you take some number, say that's 10, and this y value was like 0, 10 minus 0 is 10. So let's say that that's 10. And let's say that this x value is over here. See, and this value is 0. Let's say this x value is -3. And this x value is 4. Okay? So to get your run, you'd have to take 4 minus a -3. Just kind of, I'm throwing something at you that you're going to definitely run into. So the 10 minus 0 is easy because that's a positive number, right? So we get 10 over 7. So you're like, wait a minute, but that's 4 minus 3, right? No, it's 4 minus -3. 4 minus -3. So if you were going to kind of like draw where the x and y axis, it would kind of be like right here. So this would be like 4 comma, this point would be 4 comma 10, and this would be 0, 0, and this would be -3 comma 0. So you went 4 spaces to get back to the origin, and then you went 3 more spaces to get to -3. That's why it's a positive 7. Okay, so I move up, I move over 7 and up 10. But when we calculate slope, you always do the up down divided by the left right. Okay, so now that's basically slope. So if you go back over that video and look at that. Now, what are some of the applications of slope? We're going to go kind of quick here. So say you have the average speed of a car, right? So you're going fast, you're going slow, you're going fast, and you notice that the steeper the line is, the greater the rate of change is. And rate of change is another word or another way to think about slope. So you've got rate of change, you've got slope, okay? You've got, well, sometimes you can say the constant rate of change. If the rate of change is constant, it's a straight line. So we'll just say rate of change, slope. As you get further along in math, so right now you may only be able to, if you want to find your rate of change, also average ROC, rate of change, right? So the only thing that you can do as a freshman algebra person is figure out the average rate of change. You can only go from point to point. You can't find out what the speed is in these regions because you weren't going from the points in that region, okay? So this is a very good way, whether you're calculating the average money in, the average speed of a car, the average height, okay, of a person as they grow. Slope is very, very powerful. Now, as you get further along in math, let's do that same curve. So if you are not in pre-calculus, you can stop the video, okay? I'm gonna go on a little bit further. It's gonna be another couple of minutes. If you are, this is gonna be very important because one of the things that calculus is attempting to do is to explain, it's really the math of change, okay? But what we're gonna be dealing with is instantaneous change, okay? So, and then if you get into higher calculus, you've got multiple things changing at the same time, and you have, you know, differential equations and things like that. So, but we're gonna stick with what you know, and we're gonna say, okay, I wanna find the rate of change at this blue point, right? Okay, but it's only one point. So you don't have the tools yet, right? Well, you'll start to develop the tools. So what we can do is we can look at this and say, well, we know we can do 2 points below and above that. And we can figure out the slope of that, just doing the y2 minus y1 divided by the x2 minus x1. Great. But that doesn't quite get it. So let's narrow. So we have what here, we have a particular, we'll call this h, a distance h in between these 2 points. And basically h, though, is like x2 minus x1, right? All right, so let's make h a little bit narrower. Okay. Okay, h is here. And so now you've got this, now you've got the rate of change that's a little bit more descriptive of that. Now, if you keep boiling this down, I should probably, if you keep drawing secant lines, okay, to this curve, eventually you're actually, really what you're looking for is this tangent line, okay? You're looking for the slope of this line, okay? Now, look at that. So you see the line that's tangent to the curve. Okay, I'm going to erase the secant lines because what we're going to do is we're going to focus on this instantaneous, instantaneous rate of change point. Okay, right there. All right, now I told you that the distance between the points when I was drawing the secant line was h. Well, what do you think the distance is between the same point? It's 0, right? But we know that if you have rise divided by 0, you have a big problem, okay? You have a problem because you can't divide by 0. So in pre-calculus, what you're going to learn is something called the limit, okay? And what I'm about to show you is what's called the derivative, okay? The derivative is the slope of the tangent line anywhere on the curve at that instantaneous x, or we'll call it c, okay? Because I'm going to try to keep the jargon the same that's standard in text, okay? So let's say that the limit as x, the limit of f of, now we want to go f of c, right? Well, basically, let me do this. Let's say that this is x, and this is your x1, this is your x2, okay? So f of x is here. F of x2 would be here. We know this distance is h, and what you'll see in your book, they'll say f of x plus h. So we need the y value here. That's this y value is f of x plus h. Okay, minus the y value at f of x, which is simply, let me write this, f of x plus h. I don't know if you can see that. Minus f of x. Okay, all divided by h. Because what isn't h the run? So you have f of x plus h minus f of x, okay? Because this point would be x plus h, okay? Divided by h. Now, but here's the thing. You want to take the limit as h goes to 0, okay? So you basically you're trying to take the limit of this slope as h goes to 0. You want to find this expression as h goes to 0, okay? And what this basically is the derivative, okay? And in calculus, and you say, well, how can you do that? Well, you'll learn about limits. You'll learn about when things are approaching but never quite reach it. What would that value be? It's sort of like, what would that value be as it approaches it? We know that if it's like 2.99999 on one side and, you know, 3.00001 in approach, it's going to be approaching 3, right? It never reaches 3, but it's approaching 3. Okay, so this is how Leibniz and Newton, two famous mathematicians who invented calculus, figured out the dividing by 0 problem. They invented the limit. Okay, so I guess if you can't figure it out, invent something new, right? So this whole thing here is generally, this is going to be the slope of the tangent line at a point, okay, at a point, slope of a tangent line at a point x, okay, also known as the derivative, slope of the tangent line to the curve, excuse me, tangent line, that's what I meant, to the curve, to the function, excuse me, let's be really proper, to the function f of x, and let's say, you know, at point C. Here goes at point C, right? At some point, right? We want to get it right at that point, right? So this is called the derivative. I just do that. YouTube's great because you can pause it, right? So you get the perfect view of that. I don't have to be perfect. This is also known as f prime of x, dum, 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 okay? So that is what you're going to know as the derivative. So just wanted to do kind of a quick lesson on the derivative, slope, some of the uses of slope. To recap, slope equals y2 minus y1 over x2 minus x1. Slope is also the same thing as saying the rate of change, okay? And then f prime of x, the slope of a tangent line at any point. You want to find the instantaneous change. Is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay. Now, we'll pause this now, and then tomorrow I'll do a video on how to actually calculate the derivative, basically the number crunching of, you know, how do you find the rate of change, the actual rate of change when you take the derivative, when you do this limit thing. All right. Thank you, and be sure to click on the subscribe button and leave your comments below. I'm sure got a lot of work to do, got a lot of improvements to make, but I just want to get this out here.